Now, okay, guys. So this is where I start to sound like an announcer. Today, what we're going to be talking about is factoring and how it all works. Welcome to algebra class. That's kind of dumb, but really, what we are going to be talking about today, it's all about factoring polynomials. But essentially, today, what we're going to talk about, we want to talk about what is factoring. We're going to talk about greatest common factor and really how this all kind of relates to the distributive property. Because ultimately, when we're doing stuff with factoring, it's essentially, if you understand the distributive property, it helps and kind of moves us to the rest of what we're going to have to know. So here's what we're going to be doing. Oh, good Lord. Thanks for that, B. All right. What we're going to do here first is just to talk about when we say factoring, what the hell we're talking about. And so this is the thing. Talk about factoring. This is a verb, right? We're going to be talking about this as a verb. It essentially means you're going to break something down. This is the worst definition ever, but it works. Break something down into two or more terms slash things being multiplied. Now, here's the deal, okay? When I say things being multiplied, what I really mean by something like this is you start with something, right? It doesn't even matter what it's going to be. Sometimes you could say factor this number. Sometimes you could say factor this term. Sometimes it could be factor this polynomial that has a lot of stuff. To factor basically means I take whatever this thing is and I'm going to rewrite it as at least two things being multiplied together. And I say things because sometimes it can be two terms. Like if I say specifically, I want to start to talk about the number, let's go 24. That's easy. Give me a factor pair for this. Anybody, it doesn't matter who it is. Just give me a factor pair. Come on, y'all. Yep, 12 and 2. 12 times 2 is a way that we could do this as a factor pair. 4 times 6 is another way that we could do this. What's another one? Oh, come on. There's two other ones. Let's see what we got. Let's get them all. What are all the factor pairs of 24? 8 and 3. That's one we could do. And 1 and 24. Okay, so we've got them all. These are all ways that we can factor a number because you're essentially taking it and breaking it down into things that are being multiplied. And that's the way something like this can look. But ultimately, when we're doing this from an algebraic standpoint, we're not, this is going to be involved, but a lot of what we're going to be doing is starting when something like x squared plus 10x plus 21, and you're going to write this as two things that could have been multiplied to make this work. In this case, x plus 3 and x plus 7 is a way that we could multiply two things to be able to get to a whole polynomial here. Now, listen. When I was going through as a math student, and I learned this in algebra, I'm going to tell you right now that it was kind of like we were told, hey, see that thing right now? When you're done, you should be able to look at it and just know what that is. It's got to come from your brain. So you better get going. And, I'll tell you, sometimes that helps being pushed in that way. I'm going to tell you very clearly, we're going to build up to that because I think a lot of you guys may not be able to get to the point where you can look at it and go, of course, x squared plus 10x plus 21 is x plus 3 times x plus 7. How could it not be? We've got a whole process that we're going to be going through that will help sort of think about how to build this up. But if you can see it, that's also great. My way of thinking for a lot of factoring, writing things as factors, is there are some of you that really will be able to look at the problem and get to a place where you can see how things have worked together. It's just the way that some people's minds work to be able to get to it quickly. Other people will need a process to go through. None of those things are wrong. I think that being able to get from point A to point B is all that matters. The way that you get there, I don't really care as long as you're really doing it yourself. I think that's the piece of this that I don't want to get us into is, of course, guys, every single one of these things, there's a place online that you can type it in and get it factored. So if you want to check your answers, that's cool. But the exercise of going from something like this to something like this, what's the most important is how you can get yourself there and learning the best process for you. Because you're going to be asked to do this forever in Algebra 2, and then they're going to expect that you know how to do it later. And it can't just be well, I just plugged it into this program. it has to be a little bit more of how did I think about it? Because there will come a time when you'll be getting math that they'll give you stuff like this where everything's a variable and you've got to figure out how to divide those variables up here. And it isn't going to be something where the numbers are just going to be plugged into that. So ultimately, what we're going to build up today is the idea of what does it mean to take the greatest common factor out of something, to factor that out? And then how does distributive property play into all of this? Because I think if we understand how these things are created, it's easier to understand how to take them apart. And so how we get to this from the beginning is helpful. That'll help us then, how do we get backwards to this? Okay. Now, does anybody have any questions before I start diving into sort of the specifics of this and what it looks like? Or are we okay for where we're starting? How's everybody feeling right now? Got an okay. Pretty good's all right. Do you trust that I can get you there? That's really the thing. Do you trust me right now? Nobody will hate this yet. I can't fathom you hating this because there's nothing about it that's really that complicated. It's really just, can you see what goes into something? Okay, so I think we're going to talk about GCF, but I think before I get there, I want to talk about the distributive property a little bit, because distributive property is a form of multiplication, okay? So when we're looking at this, it's a form of multiplication. Anytime we're factoring, it's essentially a form of division. So we're looking at this from two different sides. Most of the time when you think about the distributive property, the place where you'll start is you're going to start with something on the outside of parentheses and something on the inside of parentheses. So we'll have something out here. I'm going to go super simple. Let's go with like a 3. And on the inside, I'll have something like 2x plus 5. For it to be the distributive property, you got to have something in the parentheses that has at least 2 terms, something that is split by a plus or a minus, and they can't be combined, okay? So what I want to make sure that we're looking at when we're talking about this is that ultimately you're just trying to figure out, well, how did things change when we multiply these things together? So I'm really assuming that what I'm going to do is hugely review, but if it's not, stop me, all right? So we start talking about the distributive property. Anytime you get something on the outside of parentheses in terms on the inside, if we're multiplying them, distributive property just means that that thing out here has to be multiplied times both things on the inside. So when I do this, the 3 times the 2x is going to give me 6x. The 3 times the 5 is going to be 15. You're going to be left with the same number of terms that you had inside the parentheses because they are both being multiplied by the same thing. So if they can't combine here, they're not going to be able to combine here. We got 6x plus 15. So if you need anything explained on that, here's your 1 second to be able to do that. Okay, nobody asked any questions in that 1 second. So now we're going to move on to the next thing. And I'm joking a little bit, but it is going to be kind of important you have that part down. Because the other thing that we're going to start to do is multiplying things from the outside that are a little bit more complicated. So if I've got something like 16x times 2x plus 3, it's not that much more difficult when you change the number on the outside of the term being multiplied in, but it does impact what occurs. We've got to remember that we're implementing something that brings in an x, so that when I multiply variables together, I have to remember how that rule works. I'm doing a larger number, so I've got to start checking my math a little bit when I multiply these. I got to make sure that they're not going to combine. Now, all of those pieces were present when we did this one. It's just those numbers are a little smaller. So just realize the process is the same. We multiply this guy in here, and we still do the same thing. Can somebody tell me what 16 times 2 is? Because that's our first part. 16 times the 2 is going to give me what? 32 is absolutely right. And when I multiply a variable times itself, x times x, I just have to keep track of how many there are multiplied together by using the exponent. X times x is going to give me an x to the second power. And so how about if I did that 16 times the 3? What am I going to get for that? Anybody know that one? 48 is absolutely right. And when you multiply a variable times just a number that doesn't have a variable, we don't change anything. I just have to tack that guy on at the end. Again, we had 2 terms in the parentheses here. So you're only going to have 2 terms left because we're changing both of them exactly the same way. Now, is this general idea of what I'm doing here familiar when we start talking about the distributive property? Is this solid review with what we're doing, or is this something that you guys are like, okay? So here's the thing. When you're asked to factor, generally what you're being asked to do is to start with something that is already multiplied out like this. And you're being asked to say, hey, is there anything that they have in common that can be divided out of both terms? All right. Now, really and truly, your problems when you're being asked to do it with just two terms, they're not intended to be overly complicated. Most of what they're asking you to do is, can you see common factors and take them out? Because if you can do that, it starts to get your brain in a mode of like looking for things in common that will be helpful. So like I'm going to give you a basic one. If I'm going to say to factor a GCF, here, this will be a basic one. Let's go with, 12x to the second power plus 16x. Okay. If I say we're going to factor that out, I know that when I am done, I'm going to have a set of parentheses. And I know that because there's two terms here, I'm going to have two terms in the parentheses. There's going to be something on the outside of these parentheses that they have in common. And whatever I divide it out is going to be left over in here. So I'll tell you how I think about these first. What I look at first is not the numbers, because we'll have to deal with those no matter what. Like when you're finding a GCF, there's always some common factor with the numbers that we'll figure out. Let's look at the variables first, because I think that that's the piece that you guys want to be sure you understand what's going on. In some situations, like what we ended up with up here, if only one of them has a variable, there is nothing that I can do to take that out. It's totally fine. And some of you guys are throwing out the answers, and that's absolutely right. I'm glad you kept them private because I think it's going to help me get to the talking about it. But the process is, if they both have the same variable, you can absolutely factor a variable out. But you can only factor out what they both have in common. I got x to the second power and I got x, so I can't take more than what I can bring from both. So I can only take one because this one only has one to give, and I can't start throwing out negative exponents in here. So I'm going to take an x out of both. And before I do anything else, I'm going to write what would be left behind. That plus is there because I'm not dealing with any of that. Here, I took out an x, and I know I'm going to have an x behind. Here, I took out an x, so I'm not going to leave anything behind. So now I just have to fill in what number is going to go here and what number is going to go here with what I can factor out. So let's think for a second. Can you guys think of a number that can divide out of both of these? And you can throw this out publicly. A lot of people have thrown a lot of stuff out there. 2 is absolutely a number that can be divided. 4 is another number that can be divided. And so the way I want you to think about this is, when you're looking for a number to divide out of both, what you're trying to do is find the biggest one, because you don't want to have to do work more than one time. The biggest number in this case is 4. So I want to show you what it looks like to do that, but I also want to show you what would happen if you're going to factor out something that was smaller and how you would figure out if you needed to do more work. So here, it is absolutely a 4, and then you divide both of these. 12 divided by 4 gives me the 3. 16 divided by the 4 gives me a 4. So my final factored form is 4x times 3x plus 4. Let's say we did take out the 2, okay? So I'm going to do that real quick and show you what you would have to do for that. So 12x squared plus 16x. If you had taken out a 2x instead, inside the parentheses, you would have 6x plus 8. What you always want to do real quick, just check and see if they have any common factors anymore. In this case, 6x and 8, they both have the number 2 that goes into both of them still. So it doesn't mean you can't factor that out first. You just have to remember to check your answers to see, hey, is there any more I can do? If I can pull a 2 out from here, then I should. This divided by 2 is 3x. This divided by 2 is 4. So if you notice, we have the same thing we ended up with here. You just have to keep track of all of it, and at the end of it, combine those two to get our 4 as our greatest common factor, okay? So that is, in a nutshell, the way that this works when you're talking about pulling a greatest common factor out of terms like this. And guys, it'll work whether you're dealing with things that are small like this or things that are giant and have huge number of variables. It's all the same process, right? So do you guys need any more on this specific thing, or can I move to sort of how we create some of these things differently? How's everybody feeling so far? Is everybody okay? And Will, I appreciate you saying that this actually makes sense. That's good. I would have commented on it, but clearly I was in the middle of expounding on math, and it's hard to stop a moving train here. Okay, so here's what I want you to see. Right now, there will be problems where you got to do something like this, right? Some of them will ask directly for factor out of GCF. Other times, they will say something like, hey, what are we going to do with this if you've got a bunch of crap and you got to factor something out? Um, in fact, somebody just brought something up privately about the idea that you might even have fractions and that you could do something like this. I will tell you with the general introduction of factoring these things, you're not normally going to see things with fractions. And it's not because it doesn't work. Numbers are numbers, so it doesn't matter. It's just that normally those get used a lot more when we're starting to work with things like slope, or in the case of polynomials like this, expressions where you have variables on the bottom and the top as well. Those are called rational expressions. And we will start to deal with those when we move into algebra 2. You're not going to see a ton of that right now. And so if you need a specific example with that, I can definitely throw something in, probably rolling into tomorrow. I didn't want to do this at the beginning part because I think we could probably get to more just kind of starting with the basics. But it's a really good question. What I want you to see before we go today is how do we use the distributive property when we're multiplying things like 2x plus 3 is something I used a bunch on that other page. Not multiplying just one term, but what do we do when we're multiplying two terms by this? Okay. And I feel like, but it does, I mean, I teach 2 algebra classes in addition to this one. So sometime I feel like we talked about this, but it doesn't matter. Aha! Somebody has privately used a 4-letter F word that I will throw out to you guys right now. It's FOIL, and that is absolutely the way I was taught. But I want to show you what it all means for a second, okay? What I want you to think about is just the distributive property. And the reason I want you to think about it as the distributive property first is because having an acronym to remember is nice. Hell, we used it for SOHCAHTOA. I mean, it's definitely something we can use. But I want you to see what's happening underneath it before we start using some shortcuts with that. When I say we're using the distributive property, there's a couple different ways you can look at it. You can either think of it as taking this 2-term thing and bringing it into both. So like a way to conceptualize it is to say, all right, I'm going to take this whole thing and bring it to the 2x, and I'm going to bring it to the 3. So it's like 2x times that x plus 5 plus 3 times that x plus 5. That's a way of thinking about it, is that we're distributing this whole thing to both, and then I just got to bring that 2x in, and I got to bring that 3 in. So we'll get 2x squared plus 10x, and we'll get 3x plus 15, and then I got to combine like terms. That is a way that we can look at using the distributive property to show this. And almost always, guys, the middle 2 terms are going to be our like terms that we can combine because they're just x terms. Another way we can think about this is thinking about when you distribute, let's write it the right way, I'm sorry, terms from a polynomial or a binomial into another binomial. So 2 terms to 2 terms. You could basically think about it as I am distributing that x to both terms, and then I am also distributing that 5 to both terms. So everything from this set of parentheses needs to be distributed to everything from this set of parentheses. This is a place where the idea of FOIL comes into play. X times 2x is the first thing that I would distribute. That is 2x squared. That's your first 2 terms. X times 3 is going to be 3x. That is your 2 outside terms, the outside one from this one, the outside term here. 5 times 2x is our next one, and that is going to be 10x. Those are our inside terms. And then 5 times 3 is the last distribution there. That's going to be 15. Those are our last terms. So first, outside, inside, last. Those are what these all are, which gives us our FOIL as a way of remembering what to multiply. Also a fine way of doing this. Another way that you can think about this is sort of organizing this work in individual distributions. So like if I think about this as x being distributed to the 2x plus 3, I'm going to make a graphic organizer here where I've got the x here, and I'm going to be multiplying that by the 2x plus 3 here, so I can write my 2 answers there. And then I'm also going to be writing this 5 times that same 2x plus 3. So it's essentially creating a graphic organizer just to put your 4 answers in. A lot of times we call this the box method of multiplication. It's literally the same thing as what we did here. It's just organizing them. X goes with both, 5 goes with both, and we can write all of our answers in here so that just like they're laid out here, we've just got them laid out in a box. Guys, it totally doesn't matter which one of these you use to multiply, because at the end of the day, you're going to get the same four terms. And our final answer when we multiply this is going to be 2x squared plus 13x plus 15. So what we're going to do to sort of end today and then lead into what we're going to do tomorrow, a lot of where we're going to be doing our work is how do these things work when we create these? We create these four terms, and we create this box of terms. And then how can we take that idea and work backwards to figure out, if I started with this, how can I figure out what things here created it in the first place? So with that being said, I think it's a good place for us to stop for the day.